Hello friends, today's topic is quadrilaterals, but we cannot enter this topic unless we know about triangles, and we cannot understand triangles unless we know about lines and angles. So I will start from lines and angles, come to triangles, and then we'll get into quadrilaterals. Please bear with me, just give me 15 minutes. This is very, very important because I cannot prove anything about quadrilaterals unless I use the theorems, the axioms, the corollaries that we see for triangles or for parallel lines, So I need to set some context so that I can talk about quadrilaterals. Okay, so first 15 minutes will be revision of line and angles and triangles. So what are parallel lines? First of all, let us say this is one line, this is another line. Oh, they are not in the same plane. Oh, put them in the same plane. Okay, now let us say they are like this. Oh, they are intersecting each other, so they are not parallel. But let us say that there are two lines in the same plane who never intersect each other. Such lines are called as parallel lines. Okay, then let us say that what is transversal? Transversal is another line in the same plane as the other two lines, but it is not parallel to them. So it is definitely, if it is not parallel, it is going to intersect them somewhere or the other. Such a line is called as a transversal. Okay, then what are adjacent angles? So adjacent angles means those angles who are in the same plane. So don't think about 3D, think about 2D. Okay, so in 2D context, those angles who have a common side and who have a common vertex, and they do not intersect each other's areas, and they also lie in the same plane, then they are called as adjacent angles. Means what? Let us say these are two angles, they are like this, their vertex is also the same, their side is also, they have a common side as well, then they are called as adjacent angles. But let us say that they are like this. Okay, the vertex is the same, but their side doesn't match, then they are not adjacent, so they are called as non-adjacent angles. Similarly, let us say that I put the angles something like this, so they have a common side, but one angle is only from here to here, the other angle is from here to here, then also they cross each other's area, and that's the reason why they are not adjacent angles. So as an example I gave you here, that angle A is from this common side till this side. Okay, and angle B is from this common side till this much. Okay, so some area, this area is an overlap of angle A and angle B. Since there is an overlap, they intersect each other's area. Angle A and angle B are not adjacent angles. Okay, these two can also become adjacent angles. See, these two can become adjacent angles if they fall into this, they have a common arm. So one of the sides, both the sides need to coincide with each other, and then they have to come back so that vertex also matches, then they will become adjacent angles. But at the moment the vertex is also different and the sides are also not overlapping each other, and that's why these two angles are also non-adjacent. And lastly, let us say these two angles are like this in 3D. Okay, so they do not lie in the same plane, then they are not adjacent angles, because adjacent angles is a 2D concept, so they have to come into one plane first, then they will become adjacent. Then a linear pair of angles. Now this angle and this angle, they add up to 180 degrees, and hence they are supplementary angles. So supplementary angles are also called as a linear pair of angles, because they add up to form this one line, right? And that's why they are called as linear pair of angles. These are called as vertically opposite angles. Let us say that two lines are crossing each other. Okay, so this angle is always equal to this angle. Okay, and similarly this angle is equal to this angle. Okay, then corresponding angles. So just remember all these words, because we are going to use these words while proving various theorems in quadrilaterals. Okay, so corresponding angles, these are called as corresponding angles, and corresponding angles are equal. Similarly, this angle is equal to this angle. Similarly, this angle is equal to this angle, and this angle is equal to this angle. Okay, so all the corresponding angles are equal to each other. Then alternate interior angles. Remember this word, we are going to use this word again. Alternate interior angles, okay, or they are also called as Z angles. Okay, alternate interior angles, they are equal. So what are interior angles and what are exterior angles? So whenever you have two parallel lines and one transversal, then this is external angle, this is external angle, this is external angle, this is external angle. But these 1, 2, 3, 4, these are interior angles. Why? Because they fall inside this space and this space, so they are called as interior angles, and everything outside this space and this space are called as exterior angles. Got the idea? Okay, so these are alternate interior angles, and that's why they are equal. But let us say that this angle, and this angle, they are also interior angles, but they are co-interior, means they are close to each other, they are adjacent to each other, you can say. Not adjacent angles, but you get the idea, right? We cannot use adjacent word there, and that's why they are called as co-interior angles, because they are not adjacent angles, because they don't have the same vertex. And that's why such angles are called as co-interior angles. So co-interior angles, they add up to 180 degrees. Okay, co-interior angles add up to 180 degrees. Okay, now one slide I had jumped, and this is that slide. Alternate exterior angles are also equal. So this one is an external angle, this one is an external angle, right? They are alternate, right? So that is why they are equal. Why? Because imagine that I'm bringing this line closer to this line and they merge each other. Then they become, this y will come here, right? And this angle and this angle are what? They are just like this, right? They are vertically opposite angles, right? And that is why uh, alternate exterior angles are equal to each other. Here also, if I bring this line close to this line so that they merge, then this x will come here, right? And they are vertically opposite angles, and that's why alternate exterior angles are always equal to each other. Okay, we have seen co-interior angles add up to 180 degrees. Now let us come to triangles. So triangle is any closed figure with 3 sides and 3 angles. Okay, sum of all the angles of a triangle is 180 degrees. Okay, so you can draw any kind of a shape which has 3 sides and 3 angles. It is called as a triangle. Then what are the various types of triangles? So as per the sides, they can be equilateral triangle or isosceles triangle. Here the spelling is wrong, it should be isosceles. S is missing here, it's a spelling mistake. Okay, so isosceles triangle means 2 sides are equal, and scalene triangle means all the 3 sides are of different measure. Okay, all the sides are unequal. Okay, similarly, with respect to angle, it can be an acute angle, right angle, or obtuse angle. Means what? Acute angle triangle or acute angle is the angle in which is the triangle in which all the 3 angles are acute. Acute angle means angle which is lesser than 90 degrees. Obtuse angle means angle which is greater than 90 degrees. And 90 degrees angle is called as a right angle, right? So suppose your triangle has one right angle triangle, then automatically the other two have to be acute. Why? Because sum of all the angles is equal to 180 degrees. So already there is 90, so sum of these two will also be 90, so they cannot be 90 degrees angles, right? So they are acute. So any triangle having 2 acute angles and 1 right angle triangle is called as a right angled triangle. Okay, so 1 right angle means right angle triangle. And suppose one of the angles is obtuse angle, obviously the other two will be acute. Why? Because sum of all the angles is 180 degrees. If this itself is more than 90 degrees, then the sum of these two will be lesser than 90 degrees actually. So they are so acute. Such a triangle which has at least one obtuse angle is called as obtuse angled triangle or obtuse triangle. So different people call them differently. I used to call it as acute angled triangle, right angled triangle, or obtuse angled triangle. But some people use the short form and they call them as acute triangle, right triangle, and obtuse triangle. Then what is the area of a triangle? Area of the triangle is half of base into height, which is let us say this is a base and this is the height, then half of base into height. What is the perimeter of a triangle? Perimeter means sum of all the sides, so it is a plus b plus c. What is a median? Now this is an important slide. Median of a triangle is a line segment that joins a vertex to the midpoint of the side that is opposite to that vertex. Means what? See, there are three vertices to the triangle: A vertex, B vertex, and C vertex, right? So let us say that from C vertex, I am drawing a line, a segment till the side which is opposite to it, right? But I am joining it at point P, and P is such that AP is equal to BP. Okay, so this line segment basically divides, means it crosses the opposite side at a point which divides the side into two equal parts. Then this is called as a median. So CP is the median. Okay, it divides the triangle into two smaller triangles of half the area. Means what? Area of triangle APC is equal to area of triangle CPB, which is equal to half the area of triangle CAB. How will you prove it? Okay, this is how you can prove it. What is the area of triangle ACB? It is half of base into height. Now let us consider this to be the base. So if AB is the base, I draw a perpendicular here, that is the height. So half of base into height is the area of the bigger triangle. Now let us consider this smaller triangle. What is the area of this smaller triangle? It is half of base into height, but this base itself is half of the base of the bigger triangle, right? So area of APC is equal to half the area of ABC. Similarly, you can consider triangle CPB. So area of this triangle is half of base into height. So base is again half the base of the bigger triangle. Okay, so area of this smaller triangle is also half the area of the bigger triangle. And since the area of both of them is half that of the bigger triangle, the area of both these triangles is equal. So remember, that is the reason why they gave the name median. Median means something that is the middle path, right? So median actually cuts the triangle in two equal halves. That's why it's called as a median. Now this magic continues. Let us say that we are drawing three different medians. So a triangle has three medians. So from vertex C, I am drawing this one. From vertex B also I am drawing BQ, and from vertex A also I am drawing AS. Now these medians meet at a single point, and this point is called as centroid. And this centroid is basically the center of mass of that triangle. So many of you must be in a habit of balancing different objects on your finger, right? So if you have to balance your what is that triangle called? The geometric your geometry box has, I think, a set square, right? Set square. So one set square has 90 degrees angle and 30 degrees, 60 degrees angle. Another set square has 90 degrees angle and 45 degrees angle, right? Those two set squares. So how will you balance them on your fingertip? You will draw the medians, and medians will intersect at a single point that will be called as a centroid, and you can balance it at this point. So you put your finger at centroid and it will not fall. Okay, so this median word and centroid word, both these words tell about center. Median says it's the middle path, center says it is the center of mass. Okay, that's the reason why these words are there. You learn everything using concept, so you will never forget what is median, what is centroid, because you learn by concept. Why did they give the name median? Why did they give the name centroid? Right? Now centroid divides each median into 2:1 ratio. See, the magic still continues. See, this is one median, CP is one median. So this centroid is basically dividing CP into 2:1 ratio. That means CT divided by TP is 2/1. Okay, that means CT is twice the length of TP. Okay, then what is exterior angle theorem? So it says that this is called as the exterior angle, right? And 1, 2 and 3 are called as interior angles of the triangle, right? Exterior angle, it is this angle also. If you extend this line, then this angle can also be exterior. If you extend this line, then this will also be exterior angle. If you extend this line, this will become an exterior angle, so on and so forth. Here also, if you extend this line, this is exterior angle. If you extend this line, this is an exterior angle. So let us extend this line first. So in our case, for this vertex and this line extension, this is the exterior angle, okay? And all these three are interior angles, but these two interior angles are away from the vertex under consideration, and that's why they are called as remote interior angles, okay? Now always remember that exterior angle is equal to sum of remote interior angles. How will you prove it? You will prove it like this. See, you will say that these angles 3 and 4 are supplementary angles. Why? Because these are linear angles, right? So I told you in one of the slides, linear angles, their sum is 180 degrees, right? So 3 plus 4 is equal to 180 degrees, but sum of all the angles of a triangle is also 180 degrees. I showed it in a previous slide, right? So 1 plus 2 plus 3 is also 180 degrees, and 3 plus 4 is also 180 degrees. This implies that 1 plus 2 is equal to 4, okay? So this is called as exterior angle theorem. Now, what are similar triangles? Similar triangles are those triangles which have equal angles but unequal sides, okay? So they are just similar, okay? One can be very small, another can be very big. They are similar, having equal angles, but the different sides. They are shown using this tilde sign. Where will you find it? In a keyboard, there is escape key, right? So below the escape key, whatever key is there, you shift and click on that key, so this tilde will get printed. Sorry, similar, I don't know what is that called. Tilde only, it is called tilde. And below that, whatever is there, that is backtick, okay? So press the backtick key, but with a shift, so that tilde gets printed, okay? These two triangles are similar. They are not equal, they are similar. Now, what are equal triangles? Equal triangles, as the name suggests, will have equal angles as well as equal sides. Like these two triangles have equal angles as well as equal sides. They are shown using this sign. So they are similar also, and they are equal also. That's why they are called as equal triangles. And actually, equal is not a very academic word. People normally call it congruent triangles. Instead of equal, people normally use congruent word whenever they are talking in a school environment, or whenever Euclidean geometry is referred to, then normally people call it as congruent triangles. Meaning is the same, okay? So don't call it equal triangles, say that they are congruent triangles, okay? And use this notation to indicate that both the triangles are congruent, okay? How will you type this? Well, this doesn't exist anywhere, but if you go in Word has insert symbol, and you can find it there. But an easier alternative, I'll tell you. I always tell you the easiest thing, right? So you say congruence symbol, uh, congruence symbol. That's it. Somebody must have used that symbol, right? This is that symbol. Just copy this and you paste it wherever you like. Okay, I do it like this. But yeah, there must be some keyboard shortcut for doing that, which I haven't studied so much. I just copied it from Google. Okay, now there are 5 ways of proving that two triangles are congruent. Okay, these are these 5 theorems. Okay, the first theorem says that if all the 3 sides of the two triangles are equal, then they are congruent triangles. Means if all the 3 sides are equal, then it is obvious that even their angles will be the same. So this angle will be equal to this angle will be equal to this angle, and this angle will be equal to this angle. Okay, then SAS theorem says that if two sides and the angle between them are equal, then the two triangles are congruent. ASA says that if two angles and the side between them are equal, then the two triangles are congruent. AAS says that two angles and one side is equal, then they are uh, congruent triangles. And in the case of right angle triangle, there is this right angle, hypotenuse and side theorem. So that means both of them should be right angle, so right angle. Then both the hypotenuse should be of the equal length, that's why the hypotenuse, and side, one of the sides should be of equal length, then these triangles are congruent. Obviously this side will also be equal to this side, these angles, this angle will be equal to this angle, and this angle will be equal to this angle, because these are congruent triangles. This rule is also called as, this theorem is also called as RHS theorem. Okay, we'll use all of these theorems in quadrilaterals. So remember all these theorems, you will require it. What is a quadrilateral? Now we are starting the main topic. What is a quadrilateral? Quadrilateral is any closed figure having four sides and four angles. In all the tutorials I see quadrilaterals drawn like this, and that's why I drew one of the quadrilaterals like this, which is something like it is punched inside. Okay, this is also a quadrilateral and it follows all the rules of a quadrilateral. So what one basic rule of a quadrilateral is that sum of all the angles is 180 degrees. 360 degrees. In case of triangles, we saw that sum of all the angles is 180 degrees. So in case of quadrilaterals, it is 360 degrees. Okay, it is very obvious that this one must be following it. This one might also be following it. How about this punched one? Suppose I have punched it. It looks like I have punched it from here, right? So वो थोड़ा सा चपक गया है, अंदर चला गया. So do you want to visualize? Now see, this became a very big angle, right? But at the same time, this became way acute. So this became obtuse and very, very obtuse. It is even more than 180 degrees, by the way. But then this is very, very acute. This is very, very acute, and this also became very, very acute, right? So especially this and this became very acute because it was punched in, right? And that's why sum of them always remains 360 degrees. Sum of all the angles always remains 360 degrees. Now, what are types of quadrilaterals? One is, how will you pronounce it? So it is trapezium, or trapezoid, trapezium or trapezoid. Okay. So trapezium has one pair of opposite sides parallel. Okay, so these are opposite sides, these are also opposite sides, right? So one of the pairs of opposite sides is parallel, the other is not, then it is a trapezium. But let us say that both the sides are parallel, both the pairs of opposite sides are parallel, then it will be called as a parallelogram. So here these opposite sides are also parallel and these opposite sides are also parallel. So there are various types of parallelogram. Okay, then what is a kite? Kite means there are no parallel sides. Okay, here one pair of opposite sides were parallel, here another pair of opposites, both the pairs of opposite sides were parallel. Here it says none of the sides is parallel, whether opposite side or adjacent side, anything, any of the sides is not parallel. Like this one is not parallel to this, not parallel to this, is not parallel to this, and same goes for all the others. That is this is first condition. Second condition is, although this is the case, but it is symmetric, the entire shape is symmetric across one of the diagonals. It is not symmetric across both the diagonals, it is symmetric only across one of the diagonals. So it is symmetric across this vertical diagonal. If I draw another diagonal horizontally, then yeah, of course this upper shape is smaller than the lower shape, and that's why it's not symmetric across the horizontal diagonal, but it is symmetric across the vertical diagonal. This kind of a shape is called as kite. It looks very much similar to the kite that you fly, right? And that's why it's called as kite. And then there could be quadrilaterals who don't support any of these rules, means they don't have any parallel sides also, and they don't have symmetry across one of the diagonals also. They are called as irregular quadrilaterals. So irregular quadrilateral, this is an irregular one, this is also an irregular one, which which looks like I have punched it. So all these are irregular quadrilaterals. Okay. Now let us come to parallelogram. What are types of parallelogram? So there are three major types: rhomboid, rhombus, and rectangle. Rhomboid says that adjacent sides are unequal. Both these adjacent sides are not equal. Okay. And interior angles are not right angles. So it talks about what it should not have. It's a parallelogram which should not have these two things. It should not have equal adjacent sides, and it should not have any interior angles equal to right angle. Okay, so it should not have any interior angles equal to 90 degrees. Okay, then it is a rhomboid. But let us say that adjacent sides are equal. So adjacent sides are equal, and obviously the opposite sides will also become equal. Then all the sides are equal. In short, all the sides are equal. Then it becomes rhombus. Rhomboid versus rhombus. Okay, don't get confused. Rhomboid does not have adjacent sides equal, and it does not have a right angle anywhere inside it. And rhombus, on the other hand, has all the sides equal. Okay, then rectangle is a parallelogram which has a right angle at every vertex. See, if you have one right angle, then since it is a parallelogram, you have to have all the angles equal to right angle. So all the interior angles are right angles in case of rectangle. Now, if all the sides of a rectangle are also equal, then it becomes a square. So square is a special case in rectangle where all the sides are equal also. Okay, now square can also be called as a special case in case of rhombus, because in case of rhombus, if all the angles are equal to 90 degree, then it becomes a square. So square, some people say that square is a special rectangle, some people say square is a special rhombus. Both the statements are true. Okay, but you cannot say that rhombus is a special case of rhomboid, because I have seen such articles where people say that rhomboid is often confused with rhombus. This means that they are different shapes. Okay, you should not consider them as subset, one as the subset of the other, right? And due to this statement, I have considered that rhomboid is a different shape and rhombus is also a different shape. They are both types of parallelogram, but one is that rhombus is not a subset of rhomboid. Okay, from this article I am saying that. Okay, but it's up to you. I told you the raw knowledge. Now how you want to analyze it, it's up to you. I told you the raw knowledge. These are the definitions of various shapes. Rhomboid is a parallelogram having adjacent sides unequal and interior angles are not right angles, and rhombus is a parallelogram having all sides equal. Okay, now let us come to the very first type. So we will see first trapezium, and then we'll come to parallelogram. So trapezium says that trapezium is a quadrilateral having one pair of parallel opposite sides. So these are opposite sides and they are parallel. So one pair of parallel opposite sides are there. These parallel sides of a trapezium are called as bases. So they are bases, and the non-parallel sides are called as legs. So this one and this one are legs. So bases, legs. Okay. Now, various types of trapezium are shown here. This is a scalene trapezoid. Why scalene trapezoid? Because if you extend the legs, okay, so that they meet somewhere, then it will form a scalene triangle. Okay, why? Because this angle is different than this angle, right? So, and means basically it's impossible that any of the angles of these triangles are equal, and that is why that is a scalene triangle. So when you extend the legs, then it forms a triangle, and that triangle is scalene triangle, and that's why this trapezoid is also called as a scalene trapezoid. Other way of looking at it is, this trapezoid is just a part of the scalene triangle created by drawing or drawing this line which cuts this triangle, and this line is parallel to the base. Okay, uh, that is also a way of looking at it. So this scalene trapezoid is derived from scalene triangle, and that's why it's called as a scalene trapezoid. Another type is isosceles trapezoid. So here you will see that these two sides, these two, you can say the legs are of equal length, and that is why this trapezoid is called as isosceles trapezoid, because if you extend these legs, then it will make a isosceles triangle, because this angle is equal to this angle, right? So it will form a isosceles triangle. So you can consider that isosceles trapezoid is cut out of isosceles triangle, right? Similarly, let us say that there was a right angle triangle, and you cut that right angle triangle like this by drawing a line which is parallel to the base. Then the trapezoid that you get is called as right trapezoid. It will have two right angles. So any trapezoid having two right angles is called as right trapezoid, or you can also call it right angled trapezoid. How will you calculate the area of a trapezoid? Area is equal to half sum of parallel sides into distance between the parallel sides. So it is half of AB plus CD into one round bracket. Okay, so half of their sum multiplied by height. Okay, this is the area of a trapezoid. How will you prove this, by the way? So just extend the legs so that it forms a triangle. Okay, so the area of the bigger triangle will be equal to half of this base multiplied by bigger height, right? And area of the upper triangle, which is cut off, okay, that is area of this base, half of area of this base, sorry, half of base AB multiplied by height. Height is this smaller height, right? Now this bigger height minus this smaller height is the height of the trapezium. Okay, so the area of the trapezium is what? Area of the trapezium is area of the bigger triangle minus area of the upper triangle, which is cut off, right? And if you go about it, you will finally get to this equation, that area of this trapezoid is equal to half of AB plus CD into height. What is the parameter of this is a very basic thing. It is sum of all the sides. So AB, BD, DC, and CA. Add all of them, you will get the perimeter. Now that was the first type of quadrilateral, trapezium. Now we'll come to the second type of quadrilateral, which is parallelogram. So parallelogram is a quadrilateral with two pairs of parallel opposite sides, right? So this is one pair of parallel opposite sides, this is another pair of parallel opposite sides. Okay, that a quadrilateral having two pairs of parallel opposite sides is called as a parallelogram. Then sum of adjacent interior angles is 180 degrees. So that is the reason why I told you about adjacent interior angles. Adjacent interior angles means what? So imagine that these two are parallel lines, and this is the line cutting it. What is it called? Something transversal. Transversal. So suppose this is the transversal and this is these are the parallel lines. Then this angle and this angle are interior angles, right? And they are adjacent to each other, but you cannot call them adjacent angles, and that's why you have to call them by some other name. So you call them as co-interior angles. Okay, so addition of co-interior angles is what? 180 degrees, and that's why in the words of parallelogram, these are what? These are interior angles, but you don't call them co-interior angles, you call them adjacent interior angles, and that's why their sum is 180 degrees. I think this can also be called as co-interior angles of a parallelogram add up to 180 degrees. So either you call them adjacent interior angles or co-interior angles. Okay, then another thing is that opposite interior angles are equal. Okay, what does that mean? So this angle is equal to this angle. These are opposite interior angles. Similarly, this angle is equal to this angle. Okay, so opposite interior angles are equal. Then various types of parallelogram, we have already seen this: rhomboid, rhombus, rectangle. Special type of rectangle or special type of rhombus is square. What is the area of a parallelogram? It is base into height. What is the parameter of a parallelogram? It is sum of all the sides. So it is twice uh, a plus b, twice a plus b. I've made a mistake there, my bad. Yes. Okay, so this is the parameter, twice a plus b. Then uh, there are four properties of a parallelogram. This can be a very sure short question, I feel. In ninth standard especially, they'll definitely ask this question, that what are various properties of parallelogram, or probably you will be given an exercise to find something, and that will require you to use these properties of a parallelogram. So this is a very, very important slide. What are the properties of a parallelogram? Four properties. First property says that the diagonal divides it into two congruent triangles. Okay, so this is one diagonal and this is another diagonal. Consider only one diagonal at a time, this diagonal. Okay, so it is dividing the parallelogram into two triangles, DBA and DBC, right? Now this property says that, these two triangles are congruent. How will you prove it? First of all, you see that this angle and this angle have to be equal, because these are two parallel lines, and this is a transversal, right? So this is an interior angle, this is also an interior angle, and they are opposite to each other, so they are opposite interior angles. So you know that opposite interior angles are equal. So that's why ABE is equal to EDC, right? Similarly, just look at it from a different point of view. You will see that if these two are parallel lines and this is the transversal, then ADE angle and angle EBC are also alternate interior angles, and that is why they have to be equal, right? So this angle is equal to this angle and this angle is equal to this angle. So the sum of these two angles must also be equal to sum of these two angles, and that's why this angle must be equal to this angle, right? You already knew about this, by the way, but I'm just telling you. Now uh, consider these two triangles, A, B and D, and C, D and B. Okay, so this triangle and this triangle, now they have a common side. This angle is equal to this angle, so one angle is equal, and again this angle is also equal to this angle, right? So angle side angle matches angle side angle respectively. So do you remember, there are 5 ways of proving that a triangle is that two triangles are congruent. So out of them, ASA theorem was there, angle side angle theorem. So due to that angle side angle theorem, you can prove, you can very easily say that triangle ABD is congruent to triangle CDB. Okay. So this proves that the diagonal divides it into two congruent triangles. Similarly, for this diagonal also you can prove in the similar fashion. Second property is opposite sides are equal. How will you prove it? Again, if this triangle and this triangle are congruent, and see this angle matches with this angle, that means this side must be matching this side, right? And similarly, if this angle is matching this angle, that means this side must be matching this side. So just because these are congruent angles, congruent triangles, their sides must be equal to each other, right? So this again proves a second property. Third property is opposite angles are equal. So I already showed to you that this angle ABE is equal to EDC, and angle CBE is equal to angle ADE. Okay, so this is equal to this and this is equal to this. So sum of these two will be equal to sum of these two, right? And that's why this bigger angle, that is ABC, must be equal to angle ADC, this bigger angle, right? So this proves the third property also. The opposite sides are also equal. See, we have just proven that the opposite sides are equal. So AB is equal to CD. So this one side and these two angles, so ASA theorem, angle side angle theorem, can be applied. And then you can say that ABE is triangle is congruent to DEC triangle. Okay, and if they are congruent, then you will definitely say that, then this side must be equal to this side, so EC must be equal to EA, because the angles match over here, and that's why you are saying that, this must be equal to this. And similarly you'll say DE must be equal to EB, because this angle is equal to this angle. So that's why you're not matching this side with this side, you're matching this side with that side, because that angle will be, this angle is equal to this angle, right? That's the reason why you're matching it in that way. Okay, so this is how you will prove all these properties. You may be asked to prove the properties, okay, since you are in 9th standard. A very basic question, I know, but yeah, in 9th standards people ask very basic questions. Let us come to exercises. Now exercises are endless. I did not cover kites, by the way, you cover it on your own, but I'll give you a look and feel of what all questions can get asked on quadrilaterals. So most of the questions that I found were on parallelogram only. Okay, but you can also be asked about any quadrilateral in general, or you can also be asked on kite. So kite I haven't covered at all. Please do cover it. I'm very sorry I did not cover it. The first exercise that we are seeing is, if ABCD is a parallelogram and AC, CF and AE are given, then find AD. So I've mentioned all these things. So AB is given, CF is given, AE is given, and we need to find this AD. Now for this we'll be using two formulae: area of a parallelogram and area of a triangle. Okay, so first of all, area of a parallelogram means area of this parallelogram is what? Base into height. What is base? DE or AB, anything, and height is what? 8 centimeters, A. Okay, and so we know what is the area of parallelogram, we can find it out. Okay, then area of the parallelogram can also be found using this height, right? So here base is what? AD, and height is this. You're just looking at the parallelogram from a different perspective, right? So I can say half of this base into this height, or half of this base into this height. It's the same, right? So they should be equal, and if you put in all the values, you get that AD is equal to 12.8 centimeter. Let's go to another example, another exercise. It says, if E, F, G, H are the midpoints of the sides of the parallelogram ABCD, then prove that the area of EFGH is half that of ABCD. Interesting, right? So E is the center of AB, F is the center of BC. Similarly, this is also center and this is also center. So whatever is formed here, area of this blue figure is half the area of this bigger figure. Well, this also tells us that if this is true, then the sum of all the yellow triangles that you see is equal to the area of the blue figure that you find at the between. So all these are very interesting questions that can be asked. Prove it, prove it. How will you prove it? So for proving this, you will say that area of the bigger parallelogram is what? Base into height, right? Now area of a triangle is what? Half of base into height, right? Okay. Now area of triangle EHF, that means I'm just drawing one line here, and I'm considering the area of the upper triangle, that is EHF. It is what? Half of base into height. So half of base is what? EF, and height is what? Height is this much. Okay, and if you consider this will also become a parallelogram, right? AHFB will also become a parallelogram. Its area is what? It is base into height. So triangle's area is half of base into height. Parallelogram's area is base into height. So parallelogram's area is twice that of the triangle, right? Similarly, you can prove that area of triangle HGF is half the area of parallelogram HDCF, right? We can prove that. So the area which is given in blue is the sum of the areas of these two triangles. EHF and GHF, right? And the area of the bigger parallelogram ABCD is equal to the sum of areas of the smaller parallelograms that we just saw, that is ABFH and DHFC, right? So that is why, hence proved that some of the areas of triangles will be half the area of the bigger parallelogram. Okay. Now let's take another example, another exercise. It says that there is this point P. P is anywhere inside the parallelogram. Okay. And now we have to prove that area of PAB, okay, this upper triangle, plus area of triangle PDC, that means the smaller triangle, is equal to half of the area of ABCD. How will you prove it? Okay. Similarly, you can also be asked that area of this triangle should be equal to the area of this triangle, and the sum of the areas of these two triangles is half the area of the entire parallelogram. Similarly, you can be said that you can be asked that this triangle and this triangle, the addition of their area should be equal to the addition of the areas of this upper triangle and the lower triangle. Okay, so all these can be the exercises, but at the moment we are asked to prove that area of this upper triangle plus area of this lower triangle is equal to half the area of the parallelogram. Okay, so how will you prove it? First of all, just draw one perpendicular, so passing through point P. So area of this upper triangle is what? Half of base, means AB, multiplied by this height, and area of this triangle is what? Half of this base, which is CD, into the height, right? Area of parallelogram is what? Base into the total height. But you know that this total height means QR is equal to QP plus PR, right? So this is how I'm proving it. So I'll start from the area of the parallelogram, and then I'll say, okay, this height can be divided into two parts, QP and PR, and then I'll say that, okay, I can say 2 by 2 here, and so I'll keep 2 outside, and then I'll put this half inside. So AB by 2, I'll divide, I'll put this AB by 2 inside this, and so this basically is the area of the first triangle. This is the area of the second triangle. Okay, so this is how I saw that area of ABCD is equal to area of this triangle plus area of this triangle multiplied by this 2. Okay, and that's why bringing bringing this 2 in the denominator, I can say that sum of area of these two triangles is half the area of this parallelogram. Okay, so that was another exercise. Another exercise can be the area of this upper triangle plus area of this lower triangle should be equal to the sum of the areas of these two triangles, the left side triangle and right side triangle. Again, similar way, you will say that we have just proven that this area of this triangle plus area of this triangle is half the area of the parallelogram. Similarly, we can also prove that area of left triangle plus area of right triangle is equal to half the area of the parallelogram, and since the RHS is the same, the LHS must also be the same, so hence proved. Okay. So these were a few examples. I think this is the last example. I found this on Byju's, so credit to them. If quadrilateral ABC, actually it should be quadrilateral, means I should be drawing a square over there or some quadrilateral over there, but I did not find that symbol anywhere, so I have used two square brackets to make them look like a quadrilateral. But in exam you will draw a quadrilateral. Okay, so if quadrilateral ABCD is any quadrilateral, I'm not saying it's a parallelogram, so this is just a quadrilateral, and AB bisects CD. So AB is bisecting CD, but maybe CD is not bisecting AB. Okay, if CD would also bisect AB, then it would become a parallelogram, right? But this is probably a quadrilateral, that is not a parallelogram. Okay, now what do I need to prove? I need to prove that area of triangle CAB, means the upper triangle, upper bigger triangle, is equal to the area of the lower bigger triangle. How will I prove that? Okay. So first of all, remember about median. I told you about median. So AO is the median of this triangle, CAD, right? And so it divides it into two, triangles having equal area. So area of CAO is equal to area of AOD, right? So this is your point number one. Point number two, similarly, you can prove that area of COB is equal to area of DOB, right? That is your point number two. Now, point number three is area of this CAB is the addition of these two areas, right? And similarly, the area of this lower triangle, okay, DAB, is the addition of the areas of these two triangles, okay. And hence proved. If you see all the four in one go, then you will soon realize that the area of CAB is equal to area of DAB, right? So these were all the exercises that I thought of discussing. I did not discuss kites at all. Please go through the kites and go through a lot of such examples. You'll find a lot of them on various websites. So good websites are Byju's, QMath, Math Monks, or Math Monks. Monks is the correct pronunciation. Splash Learn, etc. Splash Learn, actually their diagrams were good, and that's why I showed you Splash Learn. And yeah, there is a YouTube channel also of a nice person. So this is a YouTube channel that you can go and watch. But I found his lectures very long, and hence I tried to shorten everything up into one lecture. But yeah, he also teaches with a lot of zest and vigor. He has a lot of concern. It looks like he has a lot of concern for the students. So that's why I found I thought of mentioning that as well. Okay, I don't remember his name, so otherwise I would have taken the name right away. So you can go through all of them. Study Rankers is also a very good site. Okay, so that's it. If you have any difficulties, feel free to comment. Until next time, Jai Shri Ram. ये है अमित शिरासाव, अमित शिरासाव, अमित शिरासाव, अमित शिरासाव.